Hi, let's learn composite pattern today. So, before I start off in the same old fashion, I would first tell you a problem statement, make you understand it, and then we would see the problems in it, and then moving forward to that, we would see how composite pattern leverages up this problem statement and helps us to solve it. Let's start off. So, let's say as of now I have built a very simple file system. Okay, it has a file folder and a file manager, just like in a app in a mobile. Okay, so fair enough. Let's see this. So we have a file which has a private attribute with the data type as string. Then we have a method which is public and the return type is void. Okay, so we have files and folders. So now we have a class of folder with the attribute as name, it is private and the data type is string. Then we have an attribute of list of files. Okay, like there would be a list, it is a data type which would keep a file. Okay, like a list of, like a vector of files, an array list. Fair enough. So we have a method to add a file and to show the details of the file in this folder. This is it. So we would also have a file manager there too. So file manager would contain a list of all the files and the folders, and all of them are private, and this is the data type. Then we have a method to add file. It would take up as a parameter file and the return type would be void. Basically this would just add in the list of files. Add folder, which would take up a folder, return type is void, which would add over this private attribute. Okay, folder. Then we again have the print details, which would go over all the files in the system and all the folders in the system. What I meant to say is, let's say we have a file A, B, C, and it is inside the folder A, B, C as of now. Okay. So first A, B, C would get printed due to print details, and then A, B, C. Not able to understand it clearly? Don't worry. The UML diagram is just for you to comprehend what I am trying to say, so that you also start your explanation in an interview with a UML diagram itself. To concrete this idea or a problem statement, let us see the implementation. We would have a file with the name with a string. This is it, with a name private and it is a string. Okay, then we have the show details method. Return type is void and it is public. So public return type is void and it would just print the name of the file. Let's see for the folder itself. So folder has two private attributes. One is name as string, private name as string. Then we have a list of files which is also private. Then we have a list which would hold the data type of files only. Then we have an add file which would just add this file into this files one. And then we have show details. What it would do, it would print the folder's name and then all the names of the files contained in it. Like if we call the show details of this, then this would get printed. So first, that is why I told first A, B, C and then ACP would get printed. This is why I told that. Let's see up the implementation of file manager too. We have a list of files. Okay, we have a list of files. We have a folder. So we have a folder. And then we have method to add file, which would just add this in this. Method to add folder, which would just add this into this. Both are void. Then we move forward to something known as print details. What it would do, see, everything that is kept on this file one, it would call the show details of it. Show details would do what? It would print the name of the file. We have seen it above. If not, just go back and see it. We have the folder one. If we call up the folder, what it would basically do, it would print its own name and then the name of the files contained in it. So now that you know what is basically the problem statement that is present over here, we are building up a very simple file system where file contains a name and folder contains a list of files, and file manager would manage both. Before I start discussing the problem, I would give you a hint where the main problem originated from and what is the problem. If you are a person who did his data structures and algorithms and then came here, you would kind of contradict this example that was given back on those days. What was that example? Let me remind you that so that you can correlate everything. That is, when you started learning about trees in data structures, and in the introductory videos it said that trees is very important and trees is used to implement file structure. You heard that statement. But here if you observe, we are trying to implement the file system using linear data structures. And that is what is the problem, and that is what would be the solution to this problem. So now I talked about an abstract problem itself. Now if you are not familiar with that, let us see formally what is the problem in this. So see, the very first one is dependency injection principle. What does dependency injection principle? Says that higher level modules should not directly depend upon lower level modules. It should depend on abstraction or interface. This is what told. But if you observe, the higher level module, that is the file manager, depends directly on the concrete classes but not on abstraction or interfaces. This is the first problem. Let us see the second problem. The next problem is open closed principle. Open closed principle tells us what? See, let's say tomorrow if we want to add a new type of, let's say audio files or something, then we need to change this file manager also. So this class is open for modification. But open closed principle tells us what? A class should be closed for modification and open for extension only. But this is open for modification. If you observe that tomorrow, as of now, our file structure is very simple. That is, we have a folder A and inside it we have A, B, C. But in real world, do we have only files inside a folder? Not at all. In, let's say, drive C, we have a folder name as songs, and then inside the songs we have files. If you observe that we can have folders inside folders. So here folder is only capable of having files, not anything else. And this is a problem indeed. Tomorrow if we want to extend it, then this is a very problematic thing. Let's say I did this project to learn trees, but then I eventually turned up that I can't extend it and give it in production because it can't handle the simple use case. The use case that I told, that is folder inside folder, is a primary need of a file system. Very basic file system also does have this. This is the problem here. Next, let us see the next problem. That if you observe that we are trying to visualize leaf and non-leaf differently. What I meant to say is, if you observe, we are trying to visualize folders and files differently. But if we treat files as folders only, then it should be the solution, kind of. Giving you a hint. And then the last one, single responsibility principle. Yes, single responsibility principle tells us what? A class should have only one reason to change. But if you observe, if tomorrow, if let's say instead of name, we have in the show details, we have some more extra things, or show details thing changes. Then if you observe, print details changes due to that. Or list of files is not more, we change something. So this file manager would change. One reason to change. Then if we change something in the folder, we need to change in the file manager too. So it has two reasons to change. So single responsibility principle is also violated here. Now before we move to the formal design pattern, let us have some problem solving idea to this. And let's try to solve it by intuition and then understand design pattern. If you observe, the primary reason of all the problems that we are having is because these two are considered differently. If these two were considered same, then this class would have only single responsibility principle, and tomorrow we can extend it also. And dependency injection principle is still not followed. So what we can do is we can merge both of them. We can have an interface respecting both of them, And then we can ask this file manager to inspect this interface. Then open close principle, dependency injection principle, SRP, and these all would be solved because we are now considering both of them as a single unit. So this file manager would handle only single unit. Single responsibility principle is solved. Then we have dependency injection principle. We can have both of them respect an interface, and we can tell this file manager to implement with respect to this interface. Good enough? Now, complex to add folders within folders. Now files and folders are comparatively the same. So we can add the same kind of thing inside this folder also. It's good enough. And now if you observe, as both of them are a single unit, so we are not trying to visualize folders and files differently. Single responsibility principle already solved. So you had an idea that we would kind of merge both of them, have an interface on top, and then ask the file manager to implement it. And yes, indeed, this is the idea. And this moves on to something known as composite design pattern. A very simple yet very effective that is existing out there in the industry. Someone just took up that yes, this shouldn't be done this way, this should be done this way, and it gave it a name as composite design pattern. And this is basically what we have done in our entire college life to learn nodes and leaf nodes, non-leaf nodes. Someone doesn't tell us the name, we just stumble upon in an interview. That's it. You should just knowing the terms is good enough. So now see, composite is a structural design pattern because now we need to change the structure. Changing the structure, that is why structural design pattern. That compose objects into tree-like structure. Why do we need to have tree-like structure? Because our problem statement is somewhat like this. And then work with this object as if they were individual objects. That is, just merge both of them as one and then work with them. We just talked about node, individual objects here. That is, this just tells us that leaf and non-leaf node should work with a common interface. That's it. There is nothing like leaf and non-leaf. So we have only one, and ask them to implement an interface, and that interface would be done by file manager. Let us see that in practice. So what we can do is, see, we need to consider both of them as a single unit. So to have both of them as a single unit, we need to have a link between them. A link is formed through a similarity. The similarity we had earlier is the show details that is existing between both of them. So what we can do is, we can have an interface on top and we can just name it as the show details. Anyone implements the show details and implements me is good enough as a member of my interface. Polymorphism, dependency injection principle, to have those. Now what we do is, we are having a file and it is already doing show details. So it is already implementing this. No change in file. Now if you observe, that folder would now not just add only files. It can add folders too. So folders or files, that is why changed the method to add component, changing the structure, structural design pattern. So now this would accept something of data type what? File system. So now file system has two type of classes that are implementing it, folders also, files also. So now if something is of the data type file component, then we can insert folder in it also, then we can insert file in it also. Simple enough. And then show details. Then we have the component, which would now, instead earlier it was a list of files only, it would have files of this component. And the file manager is now very simple. It would have just the root one, that is the parent folder, local disk C, and then it would call the print details. If it is a folder, it would print its file. If it is a folder, it would print its own name and then print the files under it. If it is a file, it would print its own name. So now if you observe, we don't really need to clutter our mind if it is a file or a folder. We can have anything which respects the file component. Now if you observe that we can extend this interface to anything. Okay, like this folder can have anything that implements this interface, and this file manager can manage anything that implements this interface. So dependency injection principle, higher level modules should not depend upon lower level modules, but they should depend on abstraction or interfaces. solved. So all the problems that were existing out there is solved by having a common thing in between, extracting that common thing as an interface, asking all of them to implement that interface to leverage polymorphism or dynamic method dispatch. Then we have a file manager, and I told him that worry about only this interface handle, and that's it. Okay, let's see the internal implementation of this also. File system show details. It has only a method, tells us that anyone who implements this method is a member of me. Folder which implements file system has a list of file components only. Name add component would only add in this add one. Then we have the show details which would only call the show details. So see, if it is a folder, it would again call recursively this only, and it would call show details of it, and then it would call all the files in it. If it has a folder again, it would again call it. Okay, then file which implements file system, it has a file in it and it has the show details in it. Then we have the file manager itself, which keeps just the root itself, and then it would recursively call root.dfs kind of thing. Okay, if it is the end, it would stop at that instance. See, print details, just print its own name and stop. If it is a non-leaf node, it would go inside it and it would call the method of that. It's like doing a DFS. If it is a leaf node, it would just do its work and walk out. Just like if root is equals to if root.next is equals to null, then stop at that instance. Other ways, if it is a non-leaf node, it would call itself and then the lower modules of it. Like we print the current node and then call the neighbors of it which is not visited. So this is how, very akin to tree recursion and all of this. And I assume that tree and recursion is already known by you. So now, what are the cons of this? This has comparatively no con like over engineering or anything. This is a very fit to industry and solves a broad range of problems. And this is indeed used in the industry a lot, like I've shown you. A solution other than this would have been very complex. So even if you have a very simple thing, you need to use this. What the only con that is there is, and I don't accept it as a con, I accept it as a challenge. That is, we had to find a common link so that we can put it up in an interface. But sometimes finding that functionality which is the same and then having a common interface of it is difficult, not a con itself. So writing this is comparatively a difficult thing if you have very different methods or functionalities. But if you have a similar thing, then writing this is absolutely a beauty in itself. That was it from my side. Thank you and have a nice day. Goodbye.